NASA's Parker Solar Probe makes history with closest trip to the Sun. On December 24, 2024, NASA's Parker Solar Probe achieved a historic milestone by making the closest approach to the Sun ever recorded, reaching a distance of just 3.8 million miles, approximately 6.1 million kilometers from the solar surface. This incredible feat was accomplished while the probe hurtled through the Sun's atmosphere known as the corona at an astonishing speed of 430,000 miles per hour, 700,000 kilometers per hour, making it the fastest human-made object in history. This event marks a significant leap forward in our understanding of the Sun and its effects on the solar system. Overview of the Parker Solar Probe mission. Launched on August 12, 2018. The Parker Solar Probe was designed to study the Sun's outer atmosphere and gather data to help scientists understand solar phenomena that affect not just space weather but also technology on Earth. The mission involves a series of close approaches to the Sun, utilizing 7 flybys of Venus to gradually reduce its orbit and get closer to our star. Key milestones leading up to the historic encounter. 1. Launch and initial phase 2018 to 2021. The Parker Solar Probe was launched from Cape Canaveral, Florida, and commenced its mission by performing flybys of Venus to adjust its trajectory. By 2021, the probe had made its first entry into the solar corona, gathering valuable data about the Sun's atmosphere. 2. Final Venus flyby November 6, 2024. The probe completed its last gravitational assist from Venus, putting it on a trajectory that would allow it to execute its closest approach on December 24. 3. Historic close approach December 24, 2024. The Parker Solar Probe successfully flew through the corona, setting a new record for proximity to the Sun. This milestone was confirmed by a beacon tone received on December 26, indicating that the spacecraft had survived the encounter and was operating normally. Insights and discoveries. The Parker Solar Probe's close approach to the Sun allows scientists to conduct unprecedented measurements that could revolutionize our understanding of solar physics. Key areas of focus include understanding the solar wind. The probe aims to trace the origins of the solar wind, a continuous flow of charged particles released from the Sun, and understand how it accelerates as it moves away from the Sun. Investigating corona heating. One of the long-standing mysteries in solar physics is why the corona is significantly hotter than the surface of the Sun. The Parker Solar Probe's measurements will provide critical data that could help solve this enigma. Solar energetic particles. The mission seeks to understand how high-energy particles are accelerated to nearly the speed of light during solar events, which can impact space weather and technology on Earth. Technological innovations. To withstand the extreme conditions near the Sun, the Parker Solar Probe is equipped with a cutting-edge carbon-composite heat shield. This shield can endure temperatures exceeding 1 million degrees Fahrenheit, about 560,000 degrees Celsius, while keeping the spacecraft's instruments at a stable operating temperature. The design allows the probe to collect data even in the harshest solar environments. Scientific community reactions. NASA officials and scientists widely celebrated the probe's success. Nikki Fox, NASA's Associate Administrator for the Science Mission Directorate, remarked, "Flying this close to the Sun is a historic moment in humanity's first mission to a star. The data collected will enhance our understanding of the Sun's impacts on the solar system, including the technology we rely on daily." Noor Rawafi, the project scientist for the Parker Solar Probe, emphasized that this mission is ushering in a new era of space exploration and understanding of solar phenomena. The data collected thus far has already provided insights into unexpected structures such as the switchbacks in the solar wind, which were traced back to the Sun's surface. Future missions and expectations. The Parker Solar Probe is expected to continue its research with additional close approaches planned for March 22, 2025 and June 19, 2025. Scientists anticipate that each of these encounters will yield valuable data that will further enhance our knowledge of the Sun and its influence throughout the solar system. Conclusion. The Parker Solar Probe's historic close approach to the Sun on December 24, 2024 represents a significant milestone in solar research and exploration. By venturing closer than any spacecraft has before, it not only sets a new record but also positions humanity to unlock the mysteries of our closest star. As scientists await further data from this remarkable mission, the potential for groundbreaking discoveries in solar physics remains vast and exciting. The content surrounding NASA's Parker Solar Probe and its historic close encounter with the Sun contains several counterintuitive insights that may challenge common assumptions about space exploration and our understanding of the Sun. 1. Proximity to the Sun. While 3.8 million miles seems like a significant distance in cosmic terms, it is relatively close. This challenges the intuitive sense of scale that many might have regarding distances in space. If the distance from the Sun to Earth were scaled down to a football field, the Parker Solar Probe would be just 4 yards from the end zone, indicating how close it really is to the Sun's atmosphere compared to the vastness of space. 2. Extreme temperatures. The Parker Solar Probe operates in temperatures that can exceed 1 million degrees Fahrenheit in the Sun's corona. However, the spacecraft is designed to keep its instruments at a comfortable room temperature using advanced materials like carbon foam. This highlights the counterintuitive notion that it is possible to protect sensitive equipment from extreme heat through innovative engineering, which may seem improbable given the environment. 3. Understanding solar phenomena. The mission is expected to provide insights into solar phenomena like solar wind and coronal heating, which have been long-standing mysteries. The fact that we are only beginning to understand these processes despite being in the solar system for eons is a counterintuitive realization about the limits of human knowledge and the complexities of celestial mechanics. For scientific significance, the probe's mission is described as humanity's first attempt to touch a star, which is a profound statement that may not align with many people's understanding of what it means to explore the universe. The idea that we can study a star in such detail is groundbreaking, yet it contrasts with the perception that stars are too distant and untouchable to be studied closely. 5. Technological development. The mission has been in planning and development since 1958, which indicates a long-term commitment to space exploration that may not be immediately apparent. The counterintuitive aspect here is that such advanced technology and understanding of solar physics have taken decades to achieve, suggesting that progress in space exploration often requires patience and sustained effort rather than rapid breakthroughs. 6. Impact on daily life. The information gathered from the Parker Solar Probe is expected to enhance our understanding of solar activity's impact on technology on Earth, including communications and satellite operations. This connection between solar studies and everyday technology may surprise those who view space exploration as a remote and disconnected endeavor. 7. Historical context. The probe's achievement comes after a series of planned encounters utilizing gravitational assists from Venus to navigate closer to the Sun. This reveals the intricate planning and strategic use of celestial mechanics that might not be commonly appreciated, emphasizing that exploration is often a calculated series of steps rather than a direct approach. These counterintuitive points highlight the complexities and nuances of space exploration, the nature of scientific inquiry, and the remarkable achievements made possible through human ingenuity and perseverance. NASA's Parker Solar Probe has achieved a historic milestone with its closest approach to the Sun reaching just 3.8 million miles above the solar surface on December 24, 2024. This momentous event is significant not only for the technological achievement it represents, traveling at a staggering speed of 430,000 miles per hour faster than any human-made object, but also for the scientific insights it promises to deliver about our nearest star and the broader implications for understanding stellar phenomena. One of the crucial yet often overlooked aspects of this mission is the implications of the probe's findings for solar wind research. The Parker Solar Probe is expected to provide unprecedented data regarding the solar wind, a stream of charged particles released from the Sun's upper atmosphere or corona. Understanding the solar wind is vital for predicting space weather events that can affect satellite operations, communications, and even power grid stability on Earth. The probe's instruments are designed to measure the solar wind's composition and speed, helping scientists determine its origins and acceleration mechanisms. This is significant because the solar wind plays a crucial role in shaping space weather, which has direct effects on our technology-dependent society. Additionally, the Parker Solar Probe's exploration of the corona, a region that can exceed 1 million degrees Fahrenheit, will provide insights into why this outer layer of the Sun is so much hotter than its surface. Traditional theories of solar dynamics have struggled to explain this phenomenon known as the coronal heating problem. By flying through the corona, the probe can gather direct measurements of the plasma conditions, magnetic fields, and other properties that could shed light on the processes generating this extreme heat. This research is fundamental not only for solar physics but also for astrophysics in general, as it may have implications for understanding the behavior of other stars. The probe's carbon foam shield, designed to withstand extreme temperatures and protect its delicate instruments, is another technological marvel that should not be overlooked. This engineering achievement demonstrates the advanced materials science and engineering capabilities that have developed over the last few decades. The shield can endure temperatures that would melt steel while keeping the spacecraft's instruments at a stable operational temperature. This capability is crucial for conducting high-quality scientific measurements in the harsh environment of the Sun's corona. Another significant and often underappreciated aspect of the Parker Solar Probe mission is its role in paving the way for future solar exploration. The mission is not just about collecting data, it is also a test case for new technologies and methodologies that can be applied in future missions targeting other celestial bodies. The lessons learned from this mission, ranging from spacecraft design to navigation techniques in extreme environments, will inform the development of future missions aimed at exploring stars, planets, and other solar system bodies. Moreover, the Parker Solar Probe is part of a broader scientific endeavor to understand stellar phenomena and their impacts on planetary systems, including Earth. The knowledge gained from this mission will contribute to our understanding of how solar activity influences climate patterns, space weather interactions, and even the habitability of exoplanets. This is especially relevant in the context of ongoing research into habitable worlds beyond our solar system, as understanding our Sun's behavior is crucial to identifying the potential for life in other solar systems. The excitement surrounding the Parker Solar Probe's close approach is also coupled with the anticipation of the scientific data it will transmit back to Earth. This data, which is expected to provide fresh insights into solar dynamics, will be invaluable to the scientific community. However, the initial confirmation that the probe passed safely through the solar atmosphere is only the beginning. The real challenge lies in analyzing the data collected during this close encounter. Scientists are eager to decode this information, which could lead to groundbreaking discoveries and a deeper comprehension of the Sun's workings. In summary, while the Parker Solar Probe's record-breaking closest approach to the Sun is celebrated for its speed and proximity, the broader implications of its findings in solar wind research, coronal heating, advanced engineering, and future exploration are equally significant. As scientists await the data that will emerge from this mission, the anticipation builds not just for what we will learn about our Sun, but how this knowledge will influence our understanding of stars throughout the universe and the technological advancements it may inspire for future explorations. 1. Historic close approach to the Sun. The Parker Solar Probe's recent mission marks a groundbreaking achievement in space exploration by successfully approaching within 3.8 million miles of the Sun's surface on December 24, 2024. This distance is the closest any human-made object has ever ventured towards the Sun, and it enables the probe to study the solar atmosphere known as the corona in unprecedented detail. This close proximity allows researchers to gather vital data that could enhance our understanding of solar dynamics and their effects on the solar system. 2. Unparalleled speed and technological innovation. The Parker Solar Probe reached a record speed of 430,000 miles per hour during its journey through the solar atmosphere, making it the fastest human-made object ever. This achievement is not just a matter of speed, it reflects decades of technological advancement and engineering challenges that the scientific community has faced since the inception of solar exploration missions. The probe's innovative carbon foam shield is designed to withstand extreme temperatures, ensuring that its instruments operate effectively even in the scorching conditions of the corona, which can exceed 1 million degrees Fahrenheit. 3. Scientific implications in future research. The data collected from this mission is expected to provide transformative insights into several key aspects of solar physics, including the mechanisms behind solar wind generation, the high temperatures of the corona, and the acceleration of solar particles. By understanding these processes, scientists hope to gain a deeper comprehension of not only our Sun but also the behavior of other stars and their potential impacts on planetary systems, including those that may harbor habitable conditions. The Parker Solar Probe's findings will be crucial for predicting space weather events that can affect technology on Earth, such as satellite operations and power grid stability. For significance for humanity's understanding of the universe, this mission represents a historic milestone in humanity's exploration of stars, emphasizing the importance of studying celestial bodies beyond our own planet. NASA's Associate Administrator for the Science Mission Directorate, Nikki Fox, highlighted the broader implications of this mission, noting that it allows us to understand the Sun's influence on our solar system and contributes to the search for habitable worlds beyond Earth. The Parker Solar Probe's achievements not only inspire future exploration initiatives but also deepen our connection to the cosmos and our understanding of the fundamental processes governing stellar behavior. 1. Voyager Program 1977–present. NASA's Voyager missions, launched in 1977, were designed to explore the outer planets of our solar system and then continue into interstellar space. Voyager 1 and Voyager 2 provided invaluable data about Jupiter, Saturn, Uranus, and Neptune, significantly enhancing our understanding of these planets and their moons. Voyager 1 became the first human-made object to enter interstellar space in 2012, sending back data about the heliosphere and the conditions of space beyond our solar system. The missions exemplified human ingenuity and technological advancement in space exploration, similar to the Parker Solar Probe's groundbreaking approach to studying the Sun. 2. Apollo 11 Moon Landing 1969. The Apollo 11 mission marked a monumental achievement in human space exploration when astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the Moon on July 20, 1969. This mission not only showcased the capabilities of human ingenuity but also expanded our understanding of lunar geology, the history of the solar system, and the potential for human exploration beyond Earth. The Apollo program inspired generations and set the stage for future space missions, much like how the Parker Solar Probe aims to deepen our comprehension of solar phenomena and their effects on the solar system. 3. Hubble Space Telescope, launched 1990. Since its launch in 1990, the Hubble Space Telescope has revolutionized our understanding of the universe by providing unprecedented views of distant galaxies, nebulae, and other celestial phenomena. Hubble's ability to observe in various wavelengths has led to significant discoveries, including the determination of the universe's expansion rate and insights into black holes and exoplanets. The Hubble Space Telescope's contributions to astronomy resonate with the Parker Solar Probe's mission to enhance our understanding of the Sun and its influence on the solar system, demonstrating how advanced technology can transform our knowledge of the cosmos. The recent achievements of NASA's Parker Solar Probe mark a significant turning point in solar research and our understanding of celestial phenomena. As it successfully completed its historic closest approach to the Sun on December 24, 2024, the probe has set the stage for revolutionary advancements in solar physics and space exploration. Looking ahead, several key predictions can be made regarding the implications of this mission and its future trajectory. 1. Advancements in solar physics. The data collected from Parker's Solar Probe will likely lead to groundbreaking discoveries about the Sun and its dynamics. Scientists expect to gain deeper insights into the solar wind's origin, the mechanisms behind the corona's extreme temperatures, and the acceleration of solar particles. As the probe continues its orbit with close passes scheduled every 3 months, these findings will refine existing models of solar behavior, potentially altering our understanding of solar cycles and their impacts on space weather. 2. Enhanced space weather forecasting. The Parker Solar Probe's close observations are anticipated to significantly improve space weather forecasting capabilities. Understanding solar flares and coronal mass ejections (CMEs) will help scientists predict their effects on Earth, including disruptions to satellite communications power grids and navigation systems. This enhanced predictive capability will be crucial as society becomes increasingly reliant on technology that can be affected by solar activity. 3. Broader astronomical insights. The techniques and technologies developed for the Parker Solar Probe can be applied to other astronomical missions. Future missions to other stars, particularly those aimed at studying exoplanets, may utilize similar methodologies to understand stellar behavior and the potential habitability of planets in different solar systems. The knowledge gained from the Sun can serve as a model for understanding other stars, particularly in terms of stellar winds and their interactions with planetary atmospheres. 4. Technological innovations. The engineering feats achieved in creating the Parker Solar Probe, such as its carbon foam heat shield, represent significant advancements in space technology. These innovations are likely to spur further developments in materials science, thermal protection systems, and spacecraft design. The experience gained from the Parker mission may influence the design of future spacecraft for various missions, including those targeting the outer planets or deep space exploration. 5. Increased public interest and investment in space exploration. The successful milestones of the Parker Solar Probe could lead to renewed public interest in space exploration. As more discoveries are made and communicated to the public, there may be a push for increased funding and support for NASA and other space agencies. This could result in a broader array of missions aimed at exploring not just our solar system but also beyond, encouraging international collaborations in space science. 6. Educational and outreach opportunities. The mission's success provides a wealth of educational materials for schools, universities, and public outreach programs. As new data and findings emerge, educational initiatives can be developed to engage students and the public in science, technology, engineering, and mathematics STEM fields. By sharing the excitement of solar research, NASA can inspire the next generation of scientists and engineers. 7. Long-term impacts on Earth and space policy. As we better understand the Sun's influence on Earth's climate and technology, there may be shifts in policy regarding space weather preparedness. Governments and organizations could implement more robust measures to safeguard infrastructure against solar events. Additionally, insights into solar dynamics may influence broader discussions on climate change and its interactions with solar activity. In summary, NASA's Parker Solar Probe has not only made history with its closest journey to the Sun but also opened the door to a future rich with potential discoveries and advancements. As the probe continues its mission, the scientific community eagerly anticipates how these findings will reshape our understanding of the Sun, improve space weather forecasting, enhance technology, and inspire the next generation of explorers. The future of solar research is bright, and the Parker Solar Probe is leading the way.